So hello everyone, myself Ritesh, and today we are going to start the class 12 physics. Basically the first chapter we are going to start electrostatics. Before going to start this chapter, I would like to tell few things to you because this is going to be a very long journey for ourselves. We will going to cover everything in physics, and previously as you have seen we have covered vectors and unit and measurements. Now as we are going to start a very important chapter which has going to be a major portion in JEE as well as in the NEET. Okay, so for learning this chapter or for getting the proper excellence in this chapter, you should know about the vector. That's why I covered the vector, and I hope everyone has saw this videos of vector. So so we are going to start the session. Before going to start, I will tell you that how the flow of lecture will be going to be like. See, I am not going to give you any type of PPT. I am going to write each and everything on this board. You have to make a proper note with me, and you have to solve each and every question. Whatever question I will write, I will give you a time. You have to solve it. It is going to be a proper offline class where we will try to have one-to-one conversation with you, and you have to properly solve and then answer the whatever question I am asking. Okay, and we will try to solve some basic questions as well as some good questions also which is related to your exam, and then after the end of the chapter we will do some previous year also, so that we will get a proper grip on that topic, on that chapter. Okay, and for book, if someone want to follow some book, I will also tell you what type of book you can follow. Like for physics, if you want to follow for physics, so for physics you can follow DC Pandey. Okay, DC Pandey, this is I am telling for JEE, like who is preparing for JEE, for mains and advanced, DC Pandey, that you can follow. And for NEET students, they can follow simple NCERT. For them the NCERT is sufficient. Okay, and plus if they want to do, then they can do NCERT exemplar if they want. It is not necessary. Okay, if they want to excellence, then they can do, otherwise it is not necessary. This is not necessary. If they want, they can do. Okay, and plus previous year for them, that is more than sufficient for the NEET student. But for the JEE, DC Pandey as well as NCERT exemplar, that is compulsory for them. NCERT exemplar, that is compulsory for them. It is compulsory. NEET student, JEE student has to follow this. This is a compulsory for the JEE student. NCERT exemplar and DC Pandey, if they want to follow any book. According to me, you no need of any book. Okay, if you follow my notes, if you follow what I am teaching, everything will be clear. Okay, but if you sufficiently you want to solve some book or you want to follow some book with my lectures, then you can follow DC Pandey. My most of the concepts and the most of the questions will be from the DC Pandey only. Basically it is a mixture of different books, but most of the content, more than 50% of the content you will get from the DC Pandey. And some of the questions will be good examples of NCERT exemplar also. So we will try to, and most important, like very important book which you have to follow for, that is SC Verma. Okay, Sri SC Verma sir, you have to follow this. And most of the people have a doubt, like for NEET, whether we have to solve SC Verma. The answer is no. No need to solve SC Verma for NEET student. SC Verma is very good book. You have to no need to solve. For NEET student, there is a no need to solve SC Verma. For JEE, those who want to give JEE, JEE mains and JEE advanced, for them JEE advanced you have to solve SC Verma completely, each and every question. Okay, so you have to solve SC Verma for the JEE student. Clear? So this is about the book. Some people have a doubt regarding the book, so this is about the book, what you have to do. Clear? So next, so let us start our chapter. So our chapter is, first of all, tell me whether my audio and video is clear to all or not. Whether I am clear, whether I am visible. Yeah, I am fine. No, I don't know Tamil. Okay. I ask everyone to join fast because we are going to start soon. I will wait only for 2 more minutes, then I will going to start now. Okay. So remember one thing more. Here we are going to cover each and everything. Okay. And if you have any doubt, you can ask me. You can put it in your comment. I will see and I will solve and I will tell you. Okay. And you have to follow properly. Then only you can solve each and every questions. And one more thing I will tell you, whenever we are preparing for any competitive exam, it is very important to follow one thing. Okay. Don't wander here and there. And I have seen I have seen lot of things also, that the number of people who are joining the live classes are very less. I don't know why, but we are doing this thing for you only, and the number of student I am seeing is very less. Number of student are joining the classes. That means the most of the student, they are not serious. They just wasting their time. If you want to waste your time, then do something else in spite of not doing anything. So it is important for you to come and join and do and follow everything properly, because for you only we are bringing these type of things. And if you are not, and most of the people, I think I know that most of people have a doubt, like whether the content going to be what type, or whether, if you have seen my previous lecture, unit and measurement, I have covered each and everything, each and every concept. Not a single concept has been left. So similarly, see, you can check any material or any institute, any lecture. My lecture is going to be covered all the topics, all the concept which anyone can teach. Okay, I guaranteed you. Okay, and now we are going to start. So this is everything I want to tell you, so that in during the class no one will ask me this doubt, that sir, what type of big book we have to follow and what we have to do. Okay, just my lecture will be going very flow manner. You have to follow everything in that flow. You have to solve the questions numerical, which book you have to follow. I have told everything. See, you have to be serious, then only you can qualify and you can get AIR 1 or 2. Okay, because see, qualifying exam is another thing, but getting a good rank is another thing. If you want a good rank and you want to qualify the exam and you want to enter into your dream college, then you come here and you do your study. Okay, clear? So let us start. So electrostatics. Okay, now the thing is that what is electrostatics? Okay, see, my speed will be little fast in the starting because the starting topics are very easy. So let us start. The first thing is we will start with what? First thing we will start with charge. Charge. Like, what is charge? Okay, charge. What is charge? Can anyone tell me what is charge? What is the definition of a charge? So basically, charge is defined as the intrinsic property of a matter. Property of matter. Means suppose this is some matter is there. So what is charge? Charge is an intrinsic property, means it is an internal property of a matter. We cannot see this, okay, we can't see the, like, we can't see it. So that is a charge. And everyone know there are two types of charge are there. What are the two types of charge? Okay, there are two types of charge are there. What are the two types of charge? Can anyone tell? One is positive and one is negative. That are the two types of charge. And we also know positive, sorry, we can do write in different manner also. Same charge, what? Repel or attract. Same charge will repel. Okay, and different charge will attract. Different charge will attract. This is going to be the thing. Okay, so same charges will going to repel and different charges are going to be attract. The simple thing are there, nothing so much complex. Okay, simple thing which you know properly, because from basic thing only we will build the concepts. Okay, so that is the thing. Now second thing, smallest charge. What is the smallest charge? What is the smallest charge? Smallest charge. What is the smallest charge? Can anyone tell what is the smallest charge? Smallest charge. What is the smallest charge? Smallest charge is what? E. E is defined as a smallest charge. What is the value of this E? What is the value of this E?
Good evening, sir.
Oh, good evening. What is the value of this E? The value of this E is how much? Hey, you should comment. No one is commenting. What is the value of this E? The value of E is 1.6 into 10 to the power minus 19 coulomb. Okay, that is the value of this E. There are this is not only the smallest charge, there are the smallest charges are also there, like quarks. Okay, this things are also there. It is a but if you talk about the fundamental smallest, then it is electron. Electron is the fundamental smallest, but there are the smallest charge less than electron also, that is like 2e by 3 and e by 3. Okay, plus minus like that. So these are also there. They are called as a quark. Okay, they are quark, but they are not fundamental. Okay, remember, they are not fundamental. They are not fundamental. They are not fundamental. Okay, means someone asks you what is the smallest charge and fundamental charge, then it is electron. And what is the smallest charge, then it is also electron, because it haven't mentioned whether they are talking about electron or whether they are talking about something else. Because for ourselves we always consider the smallest charge means electron, because it is fundamental, where other charges are not fundamental. Next thing is that this is some basic points. What is the mass of electron? Mass of electron is how much? 9. Mass of electron is 9.1 into 10 to the power minus 31 kg. That is the mass of electron. What is mass of proton? That is 1.67 into 10 to the power minus 27 kg. Okay, so these are the simple things. You should know all these things. Okay, simple thing. Okay, So shall I move forward? Please tell, can I move forward? Can we move? At least you should tell whether I have to, I think we have to move. Okay. Yeah. So next thing after this, like there are the some properties of charge are there. What are the properties of charge? Next topic is, so basic thing you understand about the charge. I think about charge you have basic idea. Now the next thing is properties of charge. Okay. So let us start with the properties of charge. The first property of charge is, suppose I ask you one basic thing, okay? Suppose this is a one conductor, okay? This is a one conductor and it is neutral. Then what does it mean? What is the meaning of this? Meaning. What do you infer from there? That is, number of electrons are equal to number of protons. Correct? Number of electrons are equal to number of protons. That we understand from this thing. See, most people you think that why are you telling this basic concept? When you go for advanced question, JEE advanced question, they ask from very basic only. So you or for NEET student also, they are asking the question from NCERT, lines of NCERT. So these are the lines of NCERT. Okay, you can see this. You can go and read NCERT line, but these are the lines of NCERT. That's why I am telling. So you have to be patient. Okay, that is the first thing. Second thing, suppose there is another conductor, this same conductor, what I have did, I just remove a one electron from here. I remove a one electron, minus E. So then what is the charge on this? Then there will be charge. What is the charge on this? What is the charge? The charge will be plus E. The charge will be plus E. Clear? If suppose can I remove 0.2 electron from here? Is it possible? Can I remove 0.2 electron from here? Is it possible from here? Can I remove 0.2 electron? Is it possible to remove 0.2 electron? You are not giving any response, then why should I take this class? You should at least comment whether is it possible to take 0.2 electron from this conductor. You are not giving any response, then why should I take this? Anyone should tell whether it is possible to remove this 0.2 electron. Answer is no. We can't take out this 0.2 electron. It is not possible to take 0.2 electron because why we can't take 0.2 electron? Because always remember one thing, there are some properties are there, okay? Some properties are there. The first property is charge is always quantized. That means the charge can be always, the charge Q will be always n times of E, where n is what? N will be integer, like 0, 1, 2, like that. It will be an integer. It will be a integer. So charge that can be given or it can be removed, it will be always the integral multiple of E. That is meaning of a charge is quantized. That is the first property. What is second property? Second property state that the charge is always conserved. Charge is always conserved. That means suppose there is a 1, okay, suppose these are the two conductors, okay, suppose these are the two conductors are there. Suppose inside these two conductor it has a charge of -2 coulomb, -3 coulomb and +1 coulomb, and I did something and then it moved to this second state. This is the initial state, this is the second state, and suppose this charge is +5 coulomb, this is +3 coulomb, then you have to find this charge. What is this charge? Can you tell me what is the value of this charge? What is the value of X? How to find out this X? So what we have to do? Just apply charge conservation because charge is always conserved. So what is the initial charge? -2 -3 +1 is equal to 5 +3 +x. So from here you get x is equal to how much? -2 -3 -5 -1 +1 -4 -4 -3 8 -8 -12. That is -12 coulomb. Simple. Clear? So this is how a basic one example on the basis of charge conservation. Clear? So these are the two properties. Now next move to the next property. Next property is what? What is the next property? Next property is that we can say charge always charge always exist with mass. Okay, means charge cannot exist without a mass. If there is a charge, that means there will be always a mass. That is clear. Okay, mass can exist without a charge. For example, if you take a neutron has a mass, correct? If you see, the neutron has a mass, but does it have a charge? No, it does not have a charge. So this is possible. Charge can exist, mass can exist without a charge, but charge cannot exist without a mass. Okay, so that is a very important statement. Okay, so you have to remember that statement. A charge cannot exist without mass. Okay, next is fourth property. Charge is independent of velocity. Okay, charge is independent of the velocity. Clear? Means charge does not depend upon the velocity, whereas mass depend. If you remember, if you know, mass is equal to m naught under root of 1 minus v by c square, where what is m naught? M naught is called as the rest mass. M naught is called as a rest mass. So if you see properly, you can see that generally our speed is in meter per second, 5 meter, 10 meter per second. This is how much? 3 lakh kilometer per second, like 3 lakh meters in 1 second. Okay, so that is very big value. So this ratio will be almost 0. So that is why in real lifetime our mass is equal to rest mass. But if you talking about the charge particles, then they are like in charge particle the mass is not constant because their speed will be also very high. Okay, but if you see the charge is always constant, means the charge of a charge particle is not going to depend upon the speed. Okay, if you are moving some charge particle is moving, its charge will be remain same only. If it is 1 coulomb, then it will be remain 1 coulomb. Clear? Any doubt? So these are the some basic properties of a charge. Clear? Okay. Actually say something like yes or no, whether you are able to understand or not. I am not getting responses. Clear? Okay. Now we are going to start the chapter. Okay. See, our electrostatics is going to divide into 3 parts. Basically, I am going to divide the complete 12th syllabus now. Okay, because I used to teach in proper structure manner, so you will find everything in proper structure manner from top to bottom. Okay, from bottom I will start your concept building and I will go to top, and I am guaranteed you, if you are following me, I will make you so much well that you can solve each and every question. Okay, because there will because they are not going to repeat the question, they are going to repeat the concept. Most of the students what do, I will solve previous year, I will get good marks. No, not possible, because they are going to repeat the concept, they are not going to repeat the questions. Clear? So you see, in electrostatics we will have a 3 parts. If we see, we will have a 3 parts. Clear? We will have a 3 part. Okay, this is just I am giving you the idea. First is the electrostatics base. Electrostatics means charge at rest. Okay, charge at rest. Second case we will go and study about the charge at motion, charge with motion. Clear? And third thing we will study about EM wave. That is the 3 chapters we will have, and these all 3 things we will discuss properly. So first we are starting with our main chapter, that is charge at rest. Clear? Now exactly our chapter started. So the first thing is charge at rest. Clear? Charge at rest. Okay, and we will solve the questions, all the question in the class only. Okay, and you will solve, just have a trust on you. Now let us start. The first thing is going to come here is the Coulomb's law. What is that? Coulomb's law. That is a very important law, and law means you have to just remember this law and you have to apply it. You can't change it. Okay, Most of the people are confused how to align, how to use Coulomb's law, because it is a law. You have to simply follow it, what it is saying. Some people are trying to how this Coulomb's law is came, what is the reason. We are not going to go inside this. It is a law and we have to follow this. So what this law state, the first rule of this law. There are the different rules, but we will see what are the different rules. The first rule, let us see the first rule. The first rule states that if there are the two charges, then force between them will always act along the line joining center. Their center. Students don't read these things, this line joining their center. They don't know these things. That's why they are always confused while solving the question, because they don't know these lines. These lines are very important. Line joining their center. That is the first thing. Means what you understand from there. Suppose there is a charge Q1 is there, and there is a charge Q2 is there, and suppose they both are positive charge. Okay, if I haven't mentioned something, then you always treat it as a positive charge. Suppose they two are the positive charge, so this charge will apply the force in this direction, or in this direction, or in this direction, in this direction. In which direction you have to put the direction. Means the direction will be whether in this or this, which direction. So as it is mentioned, it is always act along the line joining the center. Means this is also wrong. So which will be the correct answer? The correct answer will be, or you can say the correct direction will be what? This will be my wrong direction. This is only the correct direction, because it is line joining the center of the two charges. Clear? And and the direction of this will be here. So you can say this is a force on 1 due to 2, and this is a force on 2 due to 1. Clear? So what is you can understand the second rule from here only. What is the second rule? Then what is the second rule? The second rule states that the two forces F12 magnitude is equal to F21 magnitude. That is the thing. Their magnitude are equal. They are in opposite direction. Yes or no? Their magnitude are equal. They are in opposite direction. So from here we can say Newton Baba come into the picture. What Newton says? They are action reaction pair. They are action reaction pair. Okay sir, okay, they are action reaction pair. Clear? We haven't see the formula, we are just seeing now only the important points. Okay, well, the student don't know these points, that's why they don't able to solve the question. I have seen most of the student who is not able to apply the Coulomb's law. Okay, we will solve this type of question. There is a one rod is there, one charge is there, you have to find the force due to charge on this rod, like this type of things. Okay, we will do. We will solve all the types of questions. Just be patient. They are action reaction pair. Okay, they are action reaction pair. Then I can ask one question on this. If it is an action reaction pair, then I can ask one more question. What is the question? See the question. The question is, because from this line only, this simple line will make the question. Okay, and no one know this whether this is simple. Suppose there are the charge Q1 is there having a mass 2 kg, and there is a charge Q2 is there having a mass 3 kg. Correct? This is initially at rest. This system is at rest. Now something has happened, I don't know, but now this charge q1 is moving with a speed of 2 meter per second. Find the speed of charge q2, because they both are positive charge na, so they will move, correct or not? They will move because they are because of force of repulsion. So this direction is wrong, sorry, it will be in this direction, correct? So this way they will move, it will move in 2 meter per second in this direction, and will move in some velocity v2 in this direction. You have to find v2. Okay, you have to find v2. I have framed the question by this line only, by this single line. They are action reaction pair. Okay, now you solve and tell me what is the answer of v2 in the comment section fast. Exam make the question from this single line only. See, if this is a system, is there any external forces there? No, here the external force is 0, because these two are action reaction pair na, so that means the total internal force is 0, external force is 0, so total net force on this system is what? 0. If the net force is 0, then what does it mean? It means that momentum will be conserved. That means momentum will be conserved. So what is the initial momentum? That will be my final momentum. Initial momentum will be 0 because the system is at rest. What is the final momentum? Mass, that is 2 into this direction 2 plus 3 into this v2 is equal to 0. So from here we get v2 is equal to how much? Minus 4 by 3 meter per second. Minus 4 by 3 meter per second. Clear? Means it will move in this direction with a speed of 4 by 3 meter per second. Clear? 1.33 meter per second. Any doubt? So this is how, like from single line they will frame the question. So you have to be very much conceptually strong, then only you can solve the questions. Clear? Let's move to the next. I hope it is clear. Now so we have seen the properties of basic. Now we are seeing the laws. We have seen the basic idea about what is the law is saying. First thing, it is a central force. Second thing, what? It is action reaction pair. So from here we have learned one concept, that momentum will be conserved. Now the third thing, this, that is, this force is directly proportional to the magnitude, product of the magnitude of the two charges, and inversely proportional to distance. So from here we get F is equal to K Q1 Q2 by R square. Clear? Where what is K? K is defined as 9 into 10 to the power 9 Newton meter square per coulomb square. That is a value of K, and exact value if you will see, it will be 1 by 4 pi epsilon naught. What is epsilon naught? Epsilon naught is defined as permittivity of free space. Permittivity, we will discuss later on in detail on this permittivity of free space. Free space, and its value will be 6.65 into, sorry, not 6.65, that is different value. What different constant? It is 8.85 into 10 to the power minus 12 coulomb square Newton per meter square. Clear? So that is a basic, this is the formula. This is now people learn from here, this is Coulomb's law. No, this is not a Coulomb's law. The Coulomb's law is, this is the Coulomb's law. This is a Coulomb's law, and this is the mathematical expression of the Coulomb's law. Okay, everyone learn this Coulomb's law. That's why they are not able to solve the question. So this is about your Coulomb's law. This is, now you have to remember this formula and this basic and this concept also, then only you can solve the question. Okay, these points. So this is our Coulomb's law. Clear? Any doubt? So what is a Coulomb's law? Now remember, from here, if can I make one more point? Yes, what is one more point? And remember, this is in vacuum, this permittivity of free space, that means it is in vacuum. Clear? So what is the fourth point I can say? That my electrostatic force Fe is depend on medium. Correct? Yes, it depend upon medium. This force also depend upon medium. From here I can say this force also going to be depend upon medium. So these are the basic points about the electrostatic force. Clear? Any doubt? Okay, so now let us see some examples. So this is about the Coulomb's law. Now let us see some examples. PYQ. They have so told, suppose this is my charge Q1 and this to charge Q2 and this distance is 1 meter. Clear? This is charge Q1, this is charge Q2 and the distance is 1 meter. Correct? Okay. And the thing is that they are non-zero. They are non-zero. They are non-zero. You have to find F minimum. You have to find minimum force. Now solve. If you know Coulomb's law, then you can solve. If you have really understand what I teach, then you can solve. Otherwise, you can't solve. What is the F minimum between them? Obviously between them. Between them. What is F minimum between them? What is F minimum? So what is the formula? K Q1 Q2 1 square. So K Q1 Q2 by 1. Now if I want to make this force minimum, I have to make this the product of these two charges minimum. What is the minimum value? What is the minimum value of charge? What is the minimum value of charge? That is E. So what is the answer? KE square. Clear? That is the answer. Simple question. This is a previous year question. See, what is a simple question? Just you have to understand the concept properly. This is the base good question on the on Coulomb's law. Clear? Next, one more point that is very important when we go for the, this is the favorite of topic, this is the favorite point of JEE Advanced. They ask lot of questions on this point only, this single point. Okay, suppose there is a charge Q1 is there, okay, and suppose there is another charge Q2 is also there, okay. Suppose these two charges are there, okay. Suppose these two charges are there, and suppose there is another charge Q3 is also there, okay, and all are positive, okay. But if it is not mentioned, then you treat it as positive. So this is also this. So now tell me, what is the force due to Q2 on Q1? So force due to Q2, yeah, or we can say, what is the force on Q2? What is force on Q2 due to Q1? So force on Q2 2 due to 1 is independent independent of force due to Q3. Means what I am trying to say, whatever is the force of interaction between these two charges will not be affected by this third charges or any number of charges present there. This force which is acting on 2 due to 1 is independent of the charge Q3. That is the first point. Net force is changed. If I calculate the net force on Q2 will be changed. But the force due to this charge on this Q2 will not be affect the force that is acting between these two charges Q1 and Q2. That is an important point which you have to remember, and that is going to be used frequently. So you have to remember this point. That is very, very important point. Fourth, and it is very, very, very important. Clear? This is very important. Clear? This is a very important point. You have to remember this. Okay? Clear? So till now I think everyone is clear. So let's move to some examples. Now we will start some examples so that you will get a practice of it. So let us take one example. First example. And let us start with a good example, okay? Suppose this is a square and there is a one charge Q is here, one charge Q is also here, minus Q is here and minus Q is also here, and the side, suppose the side is A, the side is A, it is a square. It is a square. Okay, you have to find a net force on this, F net. What is F net? This is the first question. Just solve it and tell me what is the answer. What is the net force on this charge? See what you have to do, simple application. You have to solve it very simply. What you have to do, you have to, now here what you have learned in the vector, that is going to be used completely. Now see, this charge is going to attract in this direction, this charge is also going to attract in this direction, and this charge is going to repel in this direction. So we have three forces in this direction. If you will see properly, you have three forces. What is the value of this force? Can you write? Yeah, we can write, because if you are plotting the direction, no need to take the sign. Okay, just directly write the magnitude. What is the value? K Q square by A square. What is this force? This force will be K Q square by A square. And what is this force? K Q square by, what is this distance? This is A, this is A, this will be root 2A. So this is 2A square. Correct? This is 2A square. Now you tell me what is the angle is this? This angle is 90 degree. Correct? Okay, what is this angle? This angle will be 45 degree. Correct or not? This angle will be 45 degree. Can you find? Yeah, the resultant of these two will be in the middle. Correct? That I told you. And this angle will be again 90 then. Correct? So this will be what? Root 2f, and this is root 2f plus. So we will get like this. If we will see, we will have a two vector, one vector like this, one vector will like this. This vector will become root 2 times of f. F is this, and this vector is how much? If you will see, this is f by 2, and this angle is 90 degree, correct? Now how to find the magnitude? The resultant will be like this. And how to find the F net? F net will be how much? How much of F net? This square plus this square under root of this square plus this square, correct? So this square will be 2f square plus f square by 4. So 3 by 2 f, or you can say 3 by 2 k square by a square. This is my answer. Clear? And the direction will be in this way. And if you want, you can find this angle also. I told you how to find this angle. Tan theta is equal to b cos alpha upon a plus b sin alpha. Clear? So that is how you can find this angle also. Clear? So this is the some basic example. This is how you have to solve it. You will find lot of example on this type of. They will give you triangle, then they will put the charge, and they will ask you find the charge on this. Then they will give you circle, put the charge here and find the net force on this charge. Like that, they can ask anything. So I can give you any geometry now. I can give you triangle, I will keep charge here, charge here, charge here. I will ask you find the net force on this charge. Or I will keep the charge here, find the net force. And now this is geometry. This is the basic geometry. There is no physics is there. If you know vector and if you know basic geometry, you can solve this. So this is a simple thing. That is not a problem. Now let's go for some good questions. Okay. Because I am here to solve some good questions to you, so that you can clear your concepts. Let's take one good example. Okay, some good example. Suppose this is a circle and there is a 1 coulomb charge is here. This is 1 coulomb. Okay, and suppose this is your watch. Means this is 12 coulomb, this is 1 coulomb, this is 2 coulomb, 3 coulomb, 4 coulomb, 5 coulomb, 6 coulomb, 7 coulomb, 8 coulomb, 9 coulomb, 10 and 11 coulomb. Take it at opposite. It is not drawn like that, but you take it at opposite. You have to what find? You have to find F net here. F net in vector form with all the component x cap, I cap, j cap. I want the answer in I cap, j cap, k cap. In this term I want the answer. I don't want the magnitude. I want the answer in I cap, j cap and k cap. Solve it and find the F net. How we will do? See, if you can see properly, you will understand this. See, this 12 coulomb will apply the force in this direction, and this 6 coulomb also 12 coulomb will apply the force in this direction, and this also apply the force in this direction. This will be greater in magnitude, correct? So we will get the net force in this direction, correct or not? Just try to understand. See, this 12 coulomb will apply the force in this direction, downward direction, and this 6 coulomb also apply the force in this direction. As the charge is more, this magnitude, which you will get one vector in this direction, correct? Similarly, and what is this value? This value will be, let us take this distance as some value you can take. Better is to be, suppose this is r. Okay, just take it as, okay. So this will be k, and what is the value will be? It is 6k divided by r square, correct? This is my value of f, 6k by r square. Now you see properly here. Now this 5 will be cancelled by this thing. This 5 and 11 will be there now. So these two will be in this direction, correct? Okay, similarly 10 and 4 in this direction, then 9 and 3 in this direction, similarly 8 and 2 in this direction, and this is what, a 7 and 1 in this direction, like this. So you will get 1 2 3 4 5 6 vectors in this direction. If you see properly, then you have one vector in this direction, one horizontal vector in this direction, and all are having a same value of f. This angle will be how much? 30 degree, because it is a overall 360 na, so 12 divided by 3 is 30 degree. Okay, this is also 30 degree, this is also 30 degree, all are 30 degree, all are 30 degree, correct, like that. So if you see, these two vector horizontal component will be added and vertical will be subtracted. Like these two, horizontal component will be added, vertical will be subtracted. So you will get f net is equal to how much? This is my one component in downward direction, that is f here. In horizontal, what we will get? We will get f plus this, and also this also is also there. So see, in vertical these two will be added, these two, and okay, one more thing is there. If you see properly, these two vector horizontal component is getting added, vertical component are cancel out. Similarly, these two vector horizontal component is getting added, vertical is cancelling out. So you can cancel out the vertical. So you will get 2 cos, even not 2 cos, 2 cos f cos. So basically we will get 4, not 2, 4 f, sorry, you will get 4f cos 30 degree. I told you how to take the component. Okay, let me write properly, it's not coming properly. A plus 4f cos 30 degree, clear? So this is our net force. Now you just put the value, you will get the answer, just put it. So our f net will be how much? My f net will be how much? Minus k6 by r square in j cap plus 4f, 4 6 24, cos 30 means root 3 by 2, 2 will cancel out, 2 root 3. So 2 root 3 into 6k by r square in j cap, and this will be in I cap. So this is my f net, Newton, clear? This is the f net. Now this is the good question. Okay, this involve basically what? This is complete vector. Who know, the person who understand vector, they can solve it properly, easily. Okay, this is a complete vector. Okay, clear? I hope it is clear now. Okay. So let's move to the next thing is, now here we have understand what is Coulomb's law, what is the basic idea of a Coulomb's law. We have seen the important points and we have solved some basic examples. Now let us see the vector form of Coulomb's law. Now the next thing is the vector form of Coulomb's law. Okay, so vector forms of Coulomb's law. Now what is vector form? That is also very easy. If you try to understand, let me draw it here. I think in spite of that, we can do one more thing. Okay, so suppose this is my y axis, this is my x axis, and this is my z axis. Clear? This is my x axis, this is my like y, or it is better to take it as z because you people are comfortable with z only. So this is my x, y and z. These are the three axes are there, suppose. And suppose there is a one charge q1 is here and charge q2 is there. What is this is called? This is known as, if you remember my vector lecture, so you can tell what is this thing which I am drawing. What this donate? These two lines. These two lines are known as, what are these two lines? These two lines are known as, this is r1 vector, this is r2 vector, better to be said as position vector. So they are all position vectors with respect to origin. Then if I want to find the force on 2 due to 1, what is that value? Force on 2 due to 1. So I will write my force on 2 due to 1 will be, any vector can be written as magnitude into direction. The direction will be in this direction, correct? Correct. This is my r vector. What is r vector? I told you what is my r vector. R vector, if you remember, it will be how much? This will be r2 final minus initial. Clear? I told you properly. You have to always go final minus initial. So this is we are finding on q2, that means r2 minus r1. So f21 will be how much? First is magnitude k1 k q1 q2 by magnitude of r vector square into r cap. That is our direction. Now what is r cap? R cap will be r vector by magnitude of r. Correct? What is r vector? R vector is this magnitude of this thing. So if you will put here, what you will get? K q1 q2 r2 vector minus r1 vector divided by mod of r2 minus r1 vector whole cube. So this is the vector form of a Coulomb's law. Remember, f21, that means r2 minus r1. If I ask you f12, then r1 minus r2. Just you have to flip this. Okay, so that is how you have to apply the vector form of Coulomb's law. Now where to use the vector form? Many people think that okay, we study the vector form. Now where to use this vector form? How we use this vector form? Before using, you should know the few important points about this formula. What are the important points about this formula? The first point is this. Let me tell you the first important point. Charge put with sign. Okay, the charge will be put with sign. You have to put the sign when you are applying this formula. The first thing, okay, about this formula, important points about this formula. Second thing, if you are finding f12, then what do you have to do? Then you have to do r1 minus r2 vector. And if you are finding f21, then what you have to do? r2 minus r1 vector. Clear? f12 and f21. Okay, so this is the important point about this formula. This is the concept. Now you can solve any example. Let's see one example. Till here, anyone have a doubt? You can tell, or we will see one more example. One example. Clear? So suppose this is a one cube. Clear? The side of the cube is A. The cube side is A. Okay? And the charge is there. Q, 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 Q. All are positive charge, plus Q charge. Clear? Okay. Now you have to find the force on this. F net on this one. Solve. Clear? Find this F net. Now here you can't apply the formula. If you apply the formula, you won't get the answer. That is very difficult. So here we have to use the vector form. Okay. So try to understand where you have to use which formula. Okay. For mostly for the NEET student, they are always confused that where we have to apply the vector formula, where we have to apply the normal formula. You have to be very clear whenever there is a geometry type problem, this type of problems, geometry type problems, they will give you something like this in 3D, something like this. Then in that case you can't like visualize the thing properly. So it is better to use the vector form in that place. If you are able to visualize the thing properly, then no problem. But here it is not easy. So you have to use vector form. So how we will solve? Let us see how we will solve this. It is very easy. If you know the vector form, you can easily solve this. Clear? So what you have to do? First let us take this axis. What is this axis? Suppose this is x and this is my y and this is my z. Clear? So what is this coordinate? Take one origin 0, 0, 0. What will be this? This is a, 0, 0. What is this coordinate? Important thing. Now you have to write this coordinate a, 0, because it is in xy plane. So x and y will be there, z will be 0. What is this coordinate? 0, a, 0. Okay. What is this coordinate? Okay, let us write this coordinate first. What is this coordinate? This coordinate is zy plane. So it is 0, a, a. Okay. What is this coordinate? This is 0, 0, a. Okay. What is this coordinate? This coordinate in which plane? This coordinate in zx plane. So it is a, 0, 0. Now what is this point? This point is a, this point will be what? A, because it is in all the three plane x, y and z. Now you write the value. See, suppose let us give the number. This is number 1, this is number 1, this is number 2, okay, this is number 3, this is number 4, number 5, number 6, number 7 and number 8. Clear? Now what you have to do after this, like we have to write force on 1 due to 2, then force on 1 due to 3, then force on 1 due to 4, force on 1 force on 5 due force on 1 due to 5, then force on 1 due to 6, then force on 1 due to 7 and force on 1 due to 8, and then you have to add all these forces. F net, F12 plus F13, F14, F15, F16, F17, F18. These are the, it is a sum of all these forces. Now you simply add it. First you have to write this value. Now you can easily write what is the formula? K q1 q2 into r2 vector minus r1 vector divided by mod of r vector ka whole cube. So what is the force? 1 due to 2. So what is the value? K q square r2 minus r1 vector. Okay. So force on this due to 2. So you have to, this minus this you have to do. Okay. So what is the value? You will get, you will get how much? This is 0 minus a, then 0, then 0. Okay. That is minus a I cap divided by mod of a cube. Correct? Similarly here also f on 1 due to 3. So this coordinate will be how much? K q square. What is this value? This is a I cap minus a j cap divided by root 2a whole cube. Similarly f14 kq square, how much? 1 due to 4, so it will be a j cap divided by mod of a whole cube. f15, this is the charge, so it will be kq square. What is the value? It will be minus a k cap divided by mod of a cube. Correct? Any doubt? No. Now what is f16? f16, this is the, sorry, we have done some mistake. No, correct only. Yeah. f16, that means this charge. So what is this this force? This force will be kq square, and this will be like a j cap minus a k cap. It will be minus a k cap divided by mod of root 2a whole cube. What is f17? f17 will be, okay, this 2 1, so it will be kq square, so it will be minus a I cap minus a, yeah, minus a k cap, because you have to subtract, na? So yeah, it will be divided by root 2a whole cube, and last f18. So what is f18? This is the charge f18. So f18 will be kq square, and 1 to 8 you will have to subtract, so it will become minus a I cap, and yeah, minus a I cap plus a j cap and minus a k cap, sorry, a k cap divided by root 3a whole cube. Clear? So this is our all forces. Now you can individually add and you will get the net force. Clear? Any doubt? Okay. Okay. So till now we have covered in today class we have covered some basic concepts, and then we have covered this properties of charge, and then we have moved to the Coulomb's law, and then we have seen the vector forms of the Coulomb's law, and we have seen some good examples also. Now in the tomorrow's class we will solve some more numericals, and then we are going to start with the electric field. We will start with electric field and we will cover some more things. Clear? So till now just revise everything whatever we have, and whatever the things I have told you, just go through those things properly, and just revise everything, and just see, we are doing so much things for you, so we also need something in a favor for you, or you can say something as a gift from you, basically, because we are doing such a big thing, because you will know where you will find this content properly. This is going to be very in a structure manner, everything you will get properly. So I will request you, I will say you to please share this thing, so that each and every student who has a lack of that money and who is not able to pay the fee of an institution can access these things and can also make their journey more easy and go to their and do their preparation in best manner, because we are going to bring lot of things for you. For that you have to also support us. If you are not doing a support to us, we are not able to do anything. Okay, so it is also your contribution that is also important. So what you have to do, you have to share this platform to as much as number of students who has a need of this. And we are going to be soon, we are going to become in Hindi also, in different languages and other languages also, so that it will be helpful for other student also. And you should also you should tell your suggestions in the comment box. That is why it is there. You have to tell whatever the things you need from us, then only we can understand, because that only, and you have to put like also, subscribe also, because that only give us the motivation to work. Otherwise why we work? So for us it is like a motivation, then only we will go and we will do a hard work for you, so that yeah, you like it. Okay, so till now whatever we have covered, just revise it, and next class we are going to start from here, and we will go for the electric field, and we will do some more examples and more numericals on this. Till then, take care, bye bye.